Hey guys, how's it going? So today we're going to be going through this problem called Knapsack problem. In this case it's called filling supermarket bag. So let's say you're in a supermarket and you found out that there's a huge discount on some of the item you want. Unfortunately, you only have one bag with certain bag capacity. So each of the item has its own value and capacity stored in a list called values and capacities. So we need to write a function to pick the items that maximize the total value without exceeding the bag capacity, right? I know that was too mouthful, but essentially what they're saying is that we can think of, you have a bag and let's assume that this bag capacity is 8. So you can't take everything, right? So there's a limit into this thing. But the objective is essentially is that with this limit, we still want you to kind of like maximize the profit, meaning that select on the things that are going to get you the highest value. That's what they want. So in this case, kind of like let's look into from a practical point of view. So let's say that we have these items. So let's say the first item here, this is you. You say, okay, I'm going to select the first item, which has a capacity of 2, so it's fine. It's going to give you the value of 2, right? So the value of 2 is coming from here. So that's fine. You're like, okay, let me go to the next element then. The next element can get you 4. So you have the 4 capacity. Then the, what's this? The value is going to be 3. So far we know that your value is 5, right? And so far your capacity is 6, right? So this is fine, you're doing good. So you're like, okay, let's go to the next element. Now you get to 6. This is interesting because you have your capacity currently 6 and the capacity of the item that you want to get is 6. So 6 plus 6 is 12. So we definitely know that 12 is greater than 8. So you don't have enough capacity to carry these items. So you're like, okay, no, it's fine. You know what? I'm just going to pass this one. I'm going to go to the next one, which is 5. You realize that actually 5 plus 6 is actually 11. 11 is greater than 8. So you also can pick this one. So far, what you're able to make was 5. Not bad. But the question that I'm going to ask you is that, could you have done better? I think so. So let's see how. So you got 5. I mean, you could have done better, right? So let's see how. This time we come refreshed. You're like, okay, cool. I understand how the game works. So you select 2. Like, okay, fine. I'm going to give you 2. Then the value here, you're going to get 2. You're like, also, I'm going to select 5, right? Okay, your capacity so far is 7. So this is okay. Then the profit that you've made, we know that 5 comes with a profit of 4. So it's going to be 4. So far you have 6. You're like, okay, can I select 4? You can't select 4 because you have 7. So this is going to be over that 8. You can select 6 because you already have 7. It's going to be over 8. Then the maximum capacity this time that you've made is actually impressive. It's 6. So it's greater than the previous one. So essentially that's what the question wants, is that they want you to maximize the value. So I know talking about this from an English, it sounds simple, but how do we do this from code? That's what is that's the hardest part, right? So there's a pattern into this, right? The pattern is that at each element you can either take or you might not take. So you might say not take, right? It makes sense, right? So you either take or not take, and this is fine. So the first element here, let me just erase this, kind of like make it nice cleaner so that you can see. So we add this element. So you might say, okay, I'm going to take this. It's fine. You're going to take it. We're going to give you this. So it's fine. Capacity 2. So we're going to say 8 minus 2. So you left with 6. Then profit there. You're doing good. It's going to give you 2. So yeah, like, okay, I'm not going to take. Also, you might not take. So if you don't take, essentially, the capacity will still be at 8. Your profit will be at 0. So this is P, this is C, this is C, this is P. So, right? You might be like, okay, cool. At the next element, 4, no, this is branching out now. So you might say, okay, you know what? I'm going to take, right? I'm going to take. So we know that your capacity is 6, so you're like, I'm gonna take, okay, fine, we're gonna give you this one. So you have capacity 6, you're taking 4, so you're subtracting 4, then we left with what? You left with 2. Then what is your profit? Your profit is gonna be 5, because we take this 2 and we add it with this 3, so you're getting 5. So you're doing well, right? So this is your P, this is your capacity. You're like, okay, you know what, I'm not gonna take. This is another decision that you might make. So you see, this is a decision tree essentially. So you might say, okay, I'm not gonna take, it's fine. We're gonna give you that one. So if you don't take, essentially your capacity is gonna be 6, right? And your profit is gonna be 2. So it's gonna be the same. So you did not take, so it's fine. When you go to the next element, which is 6, so you make 2 decisions also here. You're like, okay, I'm not gonna take, I can take. So you can take 6. So we know that you can take 6, right? Because obviously now we're gonna subtract from here, so you're gonna give you negative. So 2 negative 6, so it's gonna get negative. So this is not gonna go anywhere. This is the end. This is our edge case. You can't go, because yes, it makes sense, guys, because the capacity, you have 2 and you wanna take 6. It's like you have $10 and you wanna buy Ferrari. So so it's not gonna happen, right? So yeah. So here, this is our edge case, so we have to go back. So you might be like, okay, you know what, I'm not gonna take. So you're still thinking, okay, you're not gonna take. Then you're gonna give it 2. You're gonna keep your profit of 5. So it's okay. We agree to that. What's the next step then? You might be like, okay, here I can take or not take. So if you take here, we were at 6, right? Yes, we were at 6. Yes, you can take 6. We have that capacity, and you can make how much? You can make 1. So it's not a lot. So yeah, I'm gonna write it for you though. Sorry about these up and down, just that I'm controlling my yeah. Anyway, here 6, capacity 6, so your capacity is gonna be 0, because 6 minus 6, but you're gonna make some little bit of profit there, so it's gonna be 1. So we know that you had 2 previously, so now you at 3, so you're doing good, not bad. But now let's assume that you say, I'm not gonna take, so it's 6 and 2. But you can see where this thing is going. Essentially, you're gonna continue, and you're gonna see that at some point you're gonna get to the point whereby you only selected 2 and you only selected 5. You can see where this thing is going, right? So it's a tree whereby you take, then you break it down again, you take, you do not take, right? So it's either you take this or not, you continue to take this or not, just like that. So essentially it brings down the term complexity to 2 to the power of n, because now this is exponential, right? It's exponential, but can we do better? Can we make it a little bit faster? Yes, we can, if we use a dynamic programming techniques, which is called memoization. So we cache some of the results. So that's what we're gonna do. Given a specific n and the capacity, yes, we can. So essentially, I know I might have probably confused you at some point, or maybe you still kind of like don't get it. It's still okay. When we get to the code, I'm definitely going to clear things up, make sure that I explain each line of code. And yeah, the best thing that I can do is to give you the best intuition, so that even if you forget the code, you can still work around some of these stuff. So it's fine. Let's get into the code. So guys, now coming to the code. So what we're going to do is that we're going to code this thing up, but before we do, I just want to create a function. So I'm creating this function so that you can reuse it when you get a similar question. So you can get a variety of these questions. So this is more like a generic function that you can use, right, at some point. So we know that it's going to take the capacity, it's going to take the weights, it's going to take the profits, it's going to take in the size of the array, right? Actually, I think I'm confusing you here, because I just want to make things easier. So I'm going to call this bag. So you remember that this is your bag, the one that you hold, and like your capacity. So these are like the capacity of the item. So I'm gonna write capacities with an S so that it's the list. Then here it's the values of the item, so it's also gonna have an S there, so that you know that it's a list of the items. So this is the size, and refers to the size of these items. Okay, so we know that if n is equals to 0, meaning that you've reached the last element, essentially you kind of like have run out of items that you can kind of like pick, and or even if like your bag is actually less than 0, less than equals to 0, right? You don't have anything, so I'm gonna return 0 here. It's safe for me to return 0, right? So just to iterate how this thing works, so we can think of like your item, your bag currently is at 8, right? As you continue to pick, like to take, and you know that we subtract your capacity, so we keep on subtracting it. So -2, -6, whatever. But you can see that as we keep on subtracting it, it's gonna get to less than 0 at some point, and it's gonna get to 0. So that is our base case. That's why we're saying if it happens that your capacity, your bag, is actually less than 0, we know that you can carry anything at this point, right? So that's what we're doing. And if it reaches, that means n equals to 0, that means you've actually went through all the elements. Hope that makes sense, right? So like I said, two ways you can go about it. You can say not take, which is still fine. So if you don't want to take, we're gonna call this function. So okay, you're not taking anything within this item, so we're gonna leave your bag the way it is. You did not take anything, it's still okay. The capacities, we're gonna give you all the elements. Values, it's fine. But because we don't want to take the current element, so you want to take the next element, we assume we want to take, so we're gonna take you there where you want to go. So we're gonna say n minus 1. So you go and take the next guy, it's fine. So take here is gonna be 0. It's gonna initialize it to 0 because actually let me scroll down. So it's gonna be equals to 0 because I'm gonna say if the current weight, so it's less than the capacity. So if the current weight, it's called no, it's supposed to be capacities. So I'm gonna say capacities, then I'm gonna pass in, what is it here, n, right? So yes, we take an n. So if the current element, the current capacity, it's actually less than or equals to what your bag, it's fine. So it's fine. We can say you can take. So take is gonna be equals to take. So when we take, essentially what we do is that we take in the value, right? Because that's what we're trying to maximize. So it's gonna be values at the nth element. It's gonna be plus. Then we call this function, right? So we're giving you that value. So you've ended. But you've ended at the cost. Obviously, we know that your bag must go down, so we're gonna subtract the capacity, like that capacity at this element. So it's gonna be bag subtract by this. Then we need to pass in the capacities and the values. We're giving you the store essentially. Then here we and go to the next element. That's fine. We don't mind that part. Then you might be like, okay, cool. What's the result then? The result is going to be, we're going to take the max because we want to maximize this, right? So not take, it's a decision tree. You've went through that direction. We don't know if you're going to get the max. We don't know. So there's another decision that you take, which is take. We don't know what will be, we just care about the max. So we don't know which direction you took, but whichever give you the max, we just want that one. Then when we're done, we just want to return the results. Right? This is pretty slow. But the question to you that I'm going to ask you is that, can we make it faster? And you probably said yes, we can, which is with dynamic programming. So I'm going to create a cache here. So our question is that we're going to cache these results. So you can think of here we have a key. So I'm going to say. So actually, I'm just going to write the key here. So I'm just going to say key equals to, what's this? It's going to be cap. It's going to be back, right? Back at the specific item. So I'm going to ask if this key, which is lookup in the dictionary, is constant. So I'm going to say if key is in cache. So this is good, efficient. I'm going to return that key, right? I'm going to return the result I meant to say. So it's going to be cache, return cache. Then I'm going to pass in the key here. Okay. So if not, we're going to cache the result. So I'm going to say cache, pass in the key here because we always created. Then I'm going to pass in here, what is the result, right? So it's going to be the result. And I think that's that. That's like the function, how it works. But now we have this function that we're given here. How do we work with this? So, okay, they made our life difficult here because they gave us the items. Then inside these items, there's values. So the first thing that I'm going to do is to try to get the length. So I'm going to say, get me the, so let's get the n, which is going to be length of, we can take the items and we can take the values. It doesn't matter, right? Because we know that each item is a value. So if no, there has to be the same size. So if not, yeah, that means, yeah, it's something else. But guys, it's like you have to have a value. So we can always look up for that edge case, but it has to be. Anyway, let me call this our function here that we created, our generic function, and I'm gonna give it so. So what do we have here? So we have the capacity. Definitely, this is your back capacity. So we pass it here. Okay, this is fine. Then what did we say we are taking also in that? We say we're taking the capacity. So I'm gonna call in the items here, but we're gonna take in from that item, we're gonna take in capacity. So I like to kind of copy and paste, just to avoid those silly typos. So it can be quite sensitive. So yeah, I'm gonna take in the items at this point. Then we pass in those values and we should be fine, looking good. So then what's the next element, which is n, right? The length. So but I'm gonna subtract here by 1 because we start to index at 0, so it's fine. I'm gonna say n here. Okay, then we can actually return this. It's fine, we can actually return this function, and I think that's that. I'm gonna try to run it. I know I always have mistakes, so there has to be a mistake. Definitely. Oh, there is no mistake. Okay, that today is going to rain, definitely. Anyway, this worked, and we actually got the results. Exciting stuff, right? So with this cache dynamic solution, essentially, we move from exponential to making our time complexity a little bit better, with from 2 to the power of n to all the way to it's going to be O of n by c. So n denoting the length of this items, and also the c denoting the what's this, the back. So yeah, then there's an edge case. I mean, there's definitely an edge case. How we doing things here? I think we might be in trouble here because this, okay, for example, let's do this. Let's say, I think we're not going to be in trouble, right? So I'm trying to think of this hard. So let's say we have 2 and 14. Is this fine? Will this work? Yeah, this is fine. Then, but what if we get 14 and 7? This is fine because we have a comma there. Okay, yeah, this is okay. So what other people tend to do, right, is that they tend to create a key, but when they create a key, let's say they create a string, so these two things can be combined like this. But it could be that the bag is 1, right? It could be that this n element is 7, so you just be careful here. But how we did it is that we created a tuple, so it's fine. There will never be an error there. So yeah, I think, guys, that's all. Thank you very much for tuning in. I really appreciate it, and I'll see you guys in the next one.